Suppose you have a time series or a sequence of data points collected at different time points. Say you have a row, and the first number represents the value of a variable collected in week 1, and the second number is the value of the same variable collected in week 2, and so on. It can be either a column or a row. Here is a row. Let's make it a column. So copy and paste this as a column. And let's make a title data. And we need another column called time. So that's basically just the time index. Let's autofill the rest. The time frequency does not need to be the same. So for example, you can have, say, the first 10 data points are collected daily, and starting from the next one is collected weekly. Then you can just change to, say, 17 and 24. So starting from the 10th data point is 1 data point per week, and you can autofill the rest. We're not going to do that. We are going to change it back to weekly data points. The first thing to do is to make a plot. So insert, the recommended plot is good, so just use the scatter plot. And there seems to be a linear trend. You can actually add the trend line, and you can add the equation of the trend line. So let's move it up here. So this equation basically says the y is the value of your data, and x is basically just time. So what this equation basically says is every week, on average, the value of your variable, on average, again, is increased by 1.74 or something like that. So the 8.5 number is not important at all. So you don't need to interpret that one. And R square is the percentage of total variation that is explained by the trend. So here what it means is around 67–68% of the variation in the data is explained by the trend, by this linear trend here. Okay, so there is actually an easy way to compute this trend coefficient, or the slope. So it's just the covariance of these two columns divided by the variance of the time column. So you'll get a number, and that number is actually the same as the slope here. So again, this number represents, on average, each week the value is increased by 1.74 or something around that. Okay, so now let's actually do regression. So go to the data tab and click on data analysis. So if data analysis is not there, go to file, more, options, and add-ins, and manage Excel add-ins, and click go, and make sure that these two are checked. So the analysis toolpack. And then click OK, and then you'll get this data analysis. And many of these tools are actually useful, but we'll only look at this regression thing here. So OK, and select Y. Y is your data column, and X is your time column. And if you have a column title, then check labels. If not, just uncheck this. Don't check the constant is 0 thing. The confidence level, you can leave it at 95%. It's kind of standard. So you can output it in any region where it's blank. And we don't really need these stats, so I'll not check all of them. Click OK. So here is the output. So we already looked at r square is the same number. R is just r square root, so they're the same thing. And adjusted r square is more useful when there are lots of variables. We only have one, so they should be around the same, and we can just use r squared. And standard error is not important. Observation is just there are 30 points. And the next important value is the f value or the p value here. So if there's only one variable, these two numbers should be the same, and they kind of represent the probability that the slope or the trend is non-zero. So here, what it means is the number is 2.5 times 10 to the power negative 8. So it means 0.000000024. So this is very small. So it means it's very, very unlikely that there's no trend, which means it's very likely that there is a trend, and the trend coefficient is around this 1.74 number. The standard error and t-stat, they are not important, and the other two important numbers are these two, so the lower 95% confidence, lower bound and upper bound. So what it means is with 95% confidence, the trend or the slope is between 1.27 and 2.2. And 95% confidence means if this thing is repeated 100 times, around 95 times the true coefficient or the true slope will be between these two numbers. So basically, it means it's highly likely that the trend is between, the linear trend coefficient is between these two numbers. And in particular, if you only care about whether it's increasing or decreasing, more than 95% of the time, this is increasing more than 1.2 per week. So that's all the relevant information, I think. So the first row is never useful. So the intercept row, we don't care whether the p-value is large or small, and we don't really want to interpret these things. Okay, so that's for linear trend. Let's get rid of everything. And let's say, suppose there is a quadratic trend. Say we have the second row, and let's do the same thing. Call this data, and then time, and again 0, 1, 2, 3, or starting from 1, 1, 2, 3, 4, 5. Okay, so the first thing is still plot this. Okay, it seems clear that we have some kind of quadratic trend. If we add the trend line here, then it's going to be wrong. It's not like this linear trend. I'm not sure if we can actually add the quadratic trend line, but we can use a polynomial and we can display the equation of the polynomial. So let's do that. Okay, so here first, the r square is actually very large, so it's almost 100% of the variation is explained by this quadratic trend. And this quadratic trend is kind of harder to interpret. It's like the value of your variable is increases by 2 times the square of the time, and then 4, and an additional 4 per week. So again, it's kind of harder to explain other strange functions, but what you can do is you can use this to predict what will happen next. So you can substitute x as a number larger than 30, and then you can actually compute the expected y value. So that's the how to kind of interpret these trend equations. Okay, so there's no way to actually compute these numbers using like covariance. So let's just directly do the regression. So again, go to data, and here we need the square. So let's first construct the two columns. So the first column, I'll actually copy the time column. So that's 1 and 2 and 3. And the next one is time squared. So it's just, it's literally just time squared. Okay, so things are filled in. And if you want something else, if you want time cubed, you can do that as well. It's just, again, it's just literally just time cubed. And you can do something more fancy like sine of time. Sine may be useful if your data is kind of seasonal. So, and the way to do that is actually very simple. It's just literally, again, it's just sine of time. So here, we will just look at the time and time square columns. So let's do regression again, and y value is actually the same. And x value, let's only select these two. If you want to select all 4 of them, you'll get the coefficients of all 4 trends. But I only select the 2, and that's x. I think I selected the wrong thing. So y is still the data, and x is these. And we still have labels, and we need to output it somewhere else. Let's do here. Okay, so now we have the stats again. So we'll first look at the p-values. So the first value to look at is here, the f value. So f value basically says whether there's no trend or there's some trend. So this number is 1.7 times 10 to the power negative 50. So it's 0.000, 50 zeros and 1 7. So it's very, very unlikely that there is no trend. So there is trend. And here it says it's also very unlikely that there is no quadratic trend. So if this number is kind of large, it's like more than 0.05, and here it's like 0.000, 34 zeros and 59. If it's more than 0.05, then it means probably there's no quadratic trend. And here it's very small as well, so it means it's very likely that there is a linear trend, both a linear trend and a quadratic trend. So that's how to interpret these p-values. Again, we usually use like 5%. So 0.05, whether it's larger or smaller. And here actually this number is larger than 0.05, so it's basically saying it's likely that there's no intercept. But again, we don't want to interpret the intercept, so we don't care about the first row. Okay, so that's the two numbers that are important, and the actual trend coefficients, again, they can be used to make predictions, but it's kind of hard to explain what this number actually means. And again, the number with 95% confidence, this number, this coefficient, is in between these two numbers, 2.6 and 5.67. And time squared, this coefficient with 95% confidence is between 1.8 and 1.9, so it's basically just around 1.9. So I think that's all the numbers you need to look at, and yeah.